Man, you white.
I'm already sitting here. Okay. Thank you.
Alright, you're recording. Let's go.
Well, I can't write fast. Okay.
Oh, you know that?
Quiet. Quiet.
Be quiet to be here after school.
Okay, so. Don't laugh at my handwriting. What you mean? Oops, that's really close. I'm sorry. Okay. And you're trying to find the. That's wrong. No, it's not. Is that wrong?
You're missing one thing.
You gotta put that H under the end.
Oh. Okay.
Alright.
Oh, I had that. I just didn't see it. Okay. And you just circled the NH, right? Circle the NH for which one you're doing. Right.
I don't really circle anything.
Oh my gosh, y'all didn't help at all.
I don't circle stuff. I just write the word.
Okay.
Hard time finding it.
Shut up, Chris.
Oh, I found it. I got you. I got you.
Hey, where's the bond to the carbon?
That's bad now.
C, is that like, okay, I got it. But this too.
He said carbon.
And the C? Oh, no, it's not.
Yeah, it is.
Oh, okay, well, alright, yeah.
Alright, so what I'm saying is, though, on your sharing arrangement, you need the carbon bond there, too.
Oh, now I see what y'all are talking about with the way it's turned. Oh, crap, okay. Alright.
So you gotta put a
I can't write like that, how do you,
This is all being
why is the
recorded.
camera?
Well, you're left-handed, though. Sound like
Yeah, that's why, okay.
turn any way you want to. They can turn sideways. They can lay on their side if they
Yeah,
want to.
okay. Yay. Okay. Oh no.
Look at it. It's not safe.
Oh, no. Are you laughing at me? You can write it if you want to.
I'm good.
That's what I thought.
You're more teacher-like.
I'm not more teacher-like. I'm...
Okay, hold on. Before you go any further, let me see what you got there. Okay, here's what can I just show you real quick what you're looking at?
Yeah, you can go ahead and do it.
No. You stay right where you are. Because you guys came and asked me about this. You came and asked me about this. You have to have the carbon on here. And this bond has to be there. So that bond has to be there.
See, I told you that's what we do with the other bond.
And that bond has to be there. So now when you get to here, yeah, I would suggest you need a carbon and a lone pair. I'd put the lone pair up here. Okay? I'd put your lone pair up here and your hydrogen down here. How about that?
Okay.
Alright?
So now I gotta change everything else. I don't know how to change it, so...
No, all I gotta do is redraw that without the lone pair. Everything else is fine.
Oh.
We should be back there listening to us. We was back there going over the lessons instead of talking.
Can you shut up, Chandler?
Chandler, you know you're recording this, right?
Oh, I'm chastising my teammate right now.
You're the one that had stage fright a while ago. What are you talking
So
about?
then how do you do this part if that's like that?
Do what part?
The next part.
You can do it.
Oh, first you're going to do the N and the H.
Which H?
Well, it's 3.04 for you.
No, the last step. That's not the last step.
That is the last step.
This one? Right here that I circled.
That's that, because you had to change it because you had carbon. You forgot to put carbon on.
Alright, listen.
Oh my gosh. Somebody else write this. I'm
There's
getting
only two
frustrated.
things you need to know.
You got this.
There's only two things you need to know. Is that an uneven arrangement?
can't even see those like that. Hey, Summer, can you
Can you turn a little bit for them?
It's uneven.
Is this an uneven arrangement?
Yeah.
It's an uneven arrangement. Just put uneven underneath so you remember that. Okay, it's an uneven arrangement. Just write the word uneven underneath there. Okay? All right. Once you know the arrangement's uneven, you need two things to have a polar molecule, or in this case, a polar location on a molecule. One is an uneven arrangement. What's the other thing you have to have?
Yeah, you gotta have electronegativity between 0.5.
An electronegativity of between 0.5 and 1.5. In other words, you have to have a polar bond. So you got to figure out the electronegativity of both the carbon to nitrogen bond and the hydrogen to nitrogen bond. And didn't you all do that?
Mm-hmm.
So put that down here for them. Well, you did one. You'll see one on yours, but you asked
yeah,
about the other.
they had two.
Yeah,
They
I
had
got the
two.
other.
Okay, put them down. Show whether it's polar or not.
What? What?
Do the paper up.
Please.
Yeah, the Mississippi one. And then now say you 3.4 minus 2.5. 3.04.
You said three.
If you had to roll down on your paper, you wouldn't have to worry about it.
And then what?
Minus 2.55. You figure out that?
Oh my gosh.
2.49. I mean, 0.49. Sorry.
Oh my gosh. What is it?
What they're doing too. You might learn
What is it?
something.
0.49.
And that's nonpolar, right?
Okay. Well, y'all agree with that? One's polar and one's nonpolar?
Yeah. No, they're both non-polar.
That's wrong.
Okay, this is definitely polar, between 0.5 and 1.5.
Are you running the other one off 0.5?
Well, there's no reason to round up because they're doing the slots. But that is really, really close, isn't it?
Yep.
Well, here's where drawing the arrows, may I? Here's where drawing the arrows helps. We know for sure that these bonds, and if they had labeled these, well, that I taught you to label it, where this is a nitrogen and hydrogen here, you'll be really, really clear that this is the two bonds that are very polar, right? And that one's awfully close, being polar, with the direction still headed there. Okay? The question then is, if these are definitely polar, and that one's awfully close, is the whole thing polar?
Yes.
Yes, the whole thing's polar. Okay? There is well, the two things you need are polar bonds and an uneven arrangement of those bonds.
Yeah, but I thought both of them had to be polar.
Well, in this case, we got one that's awfully close and two that definitely are. You know, what's the big picture here? You know, the overriding thing is that the two that definitely are override the one that's almost, right? So there's really not much question here. This is definitely polar. Thank you guys. Appreciate it. You did a good job. There you go. Give him a plant. Applause. There you go. Give him a hand. All right. Yeah, I know. Okay. Thank you. Okay, now listen. I have another question for you before we go to one more thing we're going to do. When I did the math earlier for the OH bond, I found that I had polarities or electronegativity differences of 1.3 and 0.89. And they found they have an electronegativity difference of 0.94 and 0.49 for this structure here, the NH2 structure. Okay, this is the OH structure where I did the math. This is the NH2 structure where you guys did the math. Which one, looking at those numbers, which one looks like it's going to be more polar, OH or NH3? OH. The numbers are bigger, right? Therefore, it's a reasonable, it's not unreasonable by any means to assume that the OH group, like this, has more dipole attraction than NH2 groups. Does that make sense? Is anybody that's confused by that statement? All right then. Let's do another quiz yourself. Remember, we have a test on Friday. Please pay attention. Please write this down. Yes. All right, there are your 5 choices. Determine which has the highest boiling and melting point and which has the lowest, and then explain your answer.